Hello and welcome everyone. We are happy to have you with us today for our webinar on STM32MP1 based system on modules from our partner DH Electronics. This webinar will present the major features of the STM32MP1 microprocessor and explain how to implement them with the DH Electronics system on modules. My name is Yvonne and I will be your moderator for today's event. Now, before we start, quickly some housekeeping information. You can expand your slide deck and or maximize it to full screen by clicking on the arrows in the top right corner. You can enter your questions using the Q&A widget at the bottom of your screen. And we also encourage you to discover all the other widgets that you see at the bottom of your screen. A copy of today's presentation is already available under the resource widget. And for the best viewing experience, we recommend using a wired internet connection and closing all programs or browser sessions that are running in the background. As webinars are bandwidth intensive, closing any necessary browser tabs will help conserve your bandwidth. This webcast is being streamed through your computer, so there's no dial-in number. And for the best audio quality, please make sure your computer speakers or headset are turned on and the volume is up so you can hear the presenters. As some networks cause slides to advance more slowly than others, turning off your VPN is recommended. And if your slides are behind, pushing F5 on your keyboard will refresh your page. You can find additional answers to some common technical issues located in the help widget at the bottom of your screen. So now, without further delay, I hand over to our speaker.
Thank you, Yvonne, and also welcome to this webinar from my side. So today we are talking about some system on modules based on the STM32MP1. My name is Marines and I'm one of the hardware developers from DH Electronics. And together with Andreas Geisreiter, who is the product manager of our whole system on modules team, we will guide you through this webinar today. At first, I want to give you a small overview about the agenda. Our very first topic is a small introduction about us, DH Electronics. Then we will go over to the STM32MP1 itself. And after that, we will tell you something about the usage of the MP1 in our DHCOM product portfolio. And after that, of course, every hardware needs some software. So we're also talking about some software related to the MP1. And for the very end, we're showcasing a demo application. This demo application was actually showed this year at the Embedded World, and here we can really highlight all the features and capabilities of the MP1. So at first, let's start with DH Electronics. DH Electronics exists for about 25 years, and during that time our team has grown to about 40 employees. DH itself is located in the south of Germany, so actually it's like 1 hour away from Munich. And from here we're serving the global market. And when serving the global market, we're doing this with 3 main product areas. The first one is of course our system on modules, but then we have some HMIs and we have some IoT products. And beside of our standard products, we also make some customizations of these products, so to really fit 100% the customer's needs. So like for instance, sometimes a customer is coming to us and saying, well, your HMI is fine, but I need some small modifications to it and then it will really fit 100% my needs. And in that case, we of course are able to modify these products and make it a small customized version just for our specific customer then. And beside of this customization, we're also doing complete electronic design as a service. And here it is interesting because we're not only having the hardware know-how, we're also doing the software in-house. And therefore, you have really just one company to talk to get your complete product designed. And we're also doing some trainings. We're helping in workshops. So for instance, if you're interested in finding like new ways where you could develop your products, and then we can also find out or help here with some workshops and maybe work together to figure out what is a good option for you as a customer to develop your products into the future. And beside of this, we're also a partner of ST Microelectronics as well as Aero. So here you can see the product portfolio from DH Electronics. On the left hand side you can see the DH Core and the DHCOM, and both of these are our system of modules. You see the very left one, the DH Core, is a little bit smaller. It's a solderable SOM, and beside of it, it's a DHCOM, it's a pluggable SOM. And to the right hand side, you see the DHCON and the DHMI. The DHCON is our IoT product, and this is used as an IoT gateway. So you can put this device into a switching cabinet, and from here you can put it on a D-rail and connect to all your existing electronics, or hook it up to your local network and do maybe some edge calculation. And from there you can make, maybe if you want to, like some edge calculation and put your information up to the cloud from here. And beside of this, we're having a DHMI solution, and there we are having multiple screen sizes, and we have touch technology supporting resistive touch for a lower end version, or if you want to, of course, also capacitive touch systems. And the interesting part here is that we are reusing our own DHCOM modules inside of these products. And therefore, it's very easy to adapt these products just for your needs. So like, for instance, if you say, well, an HMI is nice, but I only need a very simple one, right? Like maybe I have already a web server running, and all I want to do is have a small visualization where I want to show this website. Then you can say, well, I put like maybe a very low cost DHCOM module inside of my DHMI, and then I have a low priced version here. But on the other hand side, if you're saying, well, on the DHCON product, for instance, I want to do some heavy calculation before I'm putting my data up to the cloud, and I'm really needing a very powerful module here, which is capable of doing all the measurement and deciding which information gets pushed up to the cloud or not. Then all you have to do is you can configure this DHCON device with a very powerful SOM, and then again you have your customized version which fits your needs. But of course, a standardized product does not work out all the time, and therefore we are also doing the complete electronic design as a service. And here we are providing the full spectrum, which means we're helping in the beginning to find the concept and make your idea into a specific concept. And from then we can do all the product management. We're doing the mechanical design, of course, the hardware and software engineering. And then once the product is designed, once we're having the first prototype, then we of course also doing the approval tests. We're helping when it comes to the sourcing of the part, and we are also supporting you with the production. And on the production side, we're relying on an EMS partner, and this gives us the opportunity to scale up some products very well. So like for instance, if we're having a few hundred pieces the first year, then it's very easy for us to scale up the production to a few thousands maybe the next year. And then afterwards, of course, we're also helping with the logistics and the after-sales service. And in the very end, you as a customer have your custom solution which fits just your needs. Okay, next let's talk about the STM32MP1 itself. So ST is known for its STM32 microcontrollers, and it is very famous for it. One of the reasons for that is the fact that the STM32 series is equipped with some great peripherals, and the MP1 is no exception for this. And therefore I'd like to highlight a few of its features with a block diagram. The first being the Cortex-M4 core, which is clocked at 209 MHz. With this core you can run all your existing code you've designed for your STM32 microcontrollers without the need of a huge modification. And from here you can also make use of some of its peripherals, like for instance CAN-FD, two 12-bit digital to analog converters, as well as two advanced 16-bit motor control timers. But the MP1 is very special, because beside of the Cortex-M4 core, ST has also included a dual-core Cortex-A7 application processor, which can be used to run a real desktop operating system like Linux on it. And when it comes to such operating systems, there are multiple scenarios in which a display might be needed. And for these scenarios, ST has also included an Vivante GPU, which gives it the ability to make some vivid hardware accelerated 3D graphics animations on it. So in this slide, we also want to highlight the heterogeneous design of these chips, which means we have different cores on the same chip. And here on the left hand side, you see the Cortex-A core as well as the graphics card. And of course, this is all the high-speed I/O. This means you can connect like a display to it with a resolution of up to HD at a refresh rate of up to 60 frames per second. Or you have things like a real gigabit Ethernet connection. Or if you want to, you have multiple USB ports. But on the same time, you have on the right hand side your Cortex-M4 core, and this one is used for the real-time application. So here you can still do all the motor control, you can use it for all the sensing, and therefore you have one chip in which both worlds are connected. So for the next part, we will show you how we as DH are using the MP1 on our system of modules. So let's go. First, what are the advantages of using a system mode module? Well, there's a bunch of reasons, but I just want to highlight a few of them. The first one is you're getting a very short time to market. This is because during the development process you can really concentrate on your key features. Let's imagine you're designing a measurement device. In that case, you can really concentrate on all the sensing and all the measurement part, while at the same time the complete computing part is done on the SOM. This gives you more time to really focus on the things that actually matter for your application. But then there's another aspect which is speaking for the usage of some SOMs, which is increasing the design success. What do we mean with this? Well, the computing part can be quite complicated, and therefore there are many parts where an error might be happening during the development process. And in order to avoid this issue, you can just rely on an approved system by again using a SOM. And finally, our DHCOM SOMs are sharing a family design, which means that they are interchangeable. So maybe you've designed your hardware and in a few years you realize that maybe you want to add some software features, but then you also realize that your SOM is maybe not powerful enough anymore. And in that case, you can just pick a new DHCOM module, populate your existing baseboard with a more powerful DHCOM module, and therefore you can increase the capabilities of your product without the need of a huge redesign. So here you can see both of our system of modules. On the left you see the DHCOM and on the right you see the DH core module. If you're seeing the slide, you might wonder, why are we offering the same SoC in two different form factors, right? But before I provide you with the answers to this question, I'd just like to take the time and tell you everything about our SOMs in more details. Let's start with the DH core. You can see the DH core is a quite small circuit board with a size of only 29 by 29 millimeters. On the bottom side of the board, you can find an LGA grid. However, during the manufacturing, an LGA grid can be quite challenging because there's a risk of air bubbles inside of your solder balls, which then lead into a bad connection or might even break down over time. And in order to avoid this issue, we've already put some solder onto this LGA grid. And therefore, as a result, you're seeing an easy and safe production. And actually, it turns out that this is working so well that it even is easy and working during the prototyping process. The main component of this DH core module is its SoC, which is available in three main variants. On the left hand side, you can see that there is the Series 1, the Series 3 and the Series 7. The Series 1 is the low-end version, which is having a single Cortex-M4 core and a single Cortex-A7 core. If you need more computing power, you can also upgrade to the 3 series, which is having a dual-core Cortex-A7 instead. And if this is not enough computing power for you either, you can also upgrade to the 7 series, which is then having an additional GPU. But since the MP1 is going to target the IoT market, and therefore also the low-end variant might be connected to the internet, ST has decided to provide all of these variants with and without a dedicated cryptographics core, which can be used for hardware-accelerated encryption, decryption, or even generating hashes. And in the beginning of this year, ST has also made an upgrade to the MP1. And in this upgraded version, the Cortex-A7 cores are running with 800 MHz instead of 650 MHz. And we as DH Electronics are currently testing this new variant, and we are very confident that we are able to support this new variant on our SOM too. On the lower left corner of our SOM, you can see the PMIC, and this PMIC is the companion chip for the MP1. This PMIC is generating all the voltage levels which are required to run the MP1 and all the necessary components. So for you as a user, all you have to do is provide this SOM with a 5 volts power supply, and from here all the additional voltages like the core voltage or for instance the DDR termination levels are all generated by its own. But the ST PMIC1 is a quite powerful PMIC, and therefore we're having multiple power rails which are also routed back to the baseboard. So for instance, you can make use of the USB power switches and use them for your USB ports on your baseboard. Or if needed, you can also make use of the additional buck converter or use the 3 LDOs and generate some voltage levels required on your specific use case. On the lower right hand side, you can see the 2 MB sized quad SPI NOR flash. And you might wonder, why are we using such a small storage? I mean, this is not enough for a real operating system like Linux, right? And the reason is, we're using this quad SPI NOR flash only to store the bootloader on here. And this gives us an unbreakable design. So for instance, if the main storage, like for instance a microSD card, is breaking down over time, we have still the bootloader running inside of this chip, and therefore your system is still capable of doing some basic things. But some of our customers got us the feedback that they're really looking forward to have an all-in-one solution with a dedicated storage so that they have everything they need on this single chip. And for them, we're also having the option to put a 128 MB sized stacked NAND NOR combination on here, and this is enough for a very lightweight Linux. But we think that most of our customers are using a bigger storage, and therefore with the DH Core, you have the ability to choose your flash according to your specific needs. But the ability to choose the flash according to your needs is sometimes more a downgrade. So what we want to make clear with this slide is that you don't have to be afraid of an eMMC. Because sometimes a customer is telling, well, I really want to have the all-in-one solution and the 128 MB is also not enough for us. I need a bigger storage like an eMMC. And especially we think that eMMC is quite popular this day, and therefore we want to tell you a small trick how you can adapt with or make a design with the eMMC quite easily. And of course, the first problem is the small pitch of an eMMC housing. And therefore, this small pitch requires a quite complex PCB stack up, which then might increase the price of your circuit board. And in order to avoid this, we have a little trick, and you can reuse the not connected pins of the eMMC and route your signals over these pins. So over here, you can see an actual eMMC design. And the green lines here are the signal lines. The red lines and the blue lines are the supply lines, so it's power and ground. And when you look very closely here, you can see that there is just a bunch of these pins are actually used. And most of these pins are just not connected. And therefore, if these pins are not connected, you can use your signal lines and route your signal lines through the pins which are not connected at all. And therefore, you don't have to route them in between of your 0.5 mm pitch of this chip design. And with this trick, you can avoid a complex PCB stack up. But then there's a next issue, and this is the eMMC lifecycle management, right? Because an eMMC is a part which gets discontinued quite regularly, and then you have to figure out which eMMC should I buy next. Then you have to do all the qualification. Is it running good? Is it running bad? Is it working at all? And here there's also a solution. And this is that we are providing you with a recommendation of a new eMMC part. So because we are doing this qualification for you, and therefore we can tell you which eMMC we've tested in our scenario, and therefore you can reuse the same eMMC parts as we do. When it comes to the memory, we're supporting the maximum of the MP1, which is 1 GB of DDR3 memory. And if you see this picture right now, we've just talked about the main storage and that we didn't include an eMMC or something like this on our board. And you might wonder, why are we using 2 chips instead of 1 chip, right? I mean, there have to be some advantages. And it turns out there are. And it goes back to the fact that a single chip with a 1 GB of size is a part which is only produced by very, very few vendors. And if there is very few vendors on the market, we can run into troubles when it comes to the sourcing of the part. So for instance, if the single vendor decides maybe in a few years from now to discontinue this part, then we would run into trouble. But since we are relying on a dual chip design, and the 512 megabyte size chip is a standard component amongst many vendors, it's very likely that even though in the case that one vendor is discontinuing this chip, it's very likely that there is another vendor still on the market producing this part. And therefore, it's also very important when it comes to the long-term availability. And we as DH, we are guaranteeing that we provide all of our SOMs for at least 10 years to the market. And therefore, we really have to rely on a standard component which is available also in 10 years from now. But these are just some, I would say, like some sourcing facts and not so fancy arguments, right? And we as engineers, we want to hear like more performance-wise arguments. And it turns out that there is also some performance increasing with the 2-chip design. And thanks to this design, we can max out the bandwidth between the SoC and the memory itself, because we're using a 32-bit wide data bus here. So if you're now interested in the DH core and you say, well, I would like to start developing with this SOM, where should I start? And here you can see this is the Avenger 96. This is a reference design we've done last year together with Aero and ST Microelectronics. And here on the bottom side, we've populated our system module on there. And it's very interesting for you because if you say, well, some of these components might be interesting for my application too, you can just copy some of these components because the schematic of the Avenger 96 is open source. And therefore you can just take a look and you see we've included like an eMMC flash here. We have things like a gigabit Ethernet connection or even a Wi-Fi module and Bluetooth module. There is an HDMI connector and many, many more. And if you say some of these components might be interesting for your application too, you can just take a look at the schematic of the Avenger 96 board and use it as a reference for your design. So these are all the features about the DH core. So next, let's talk about the DHCOM module. The first main components of the DHCOM module is of course its SODIMM connector and its high-speed connector. And these connectors are standardized throughout all the DHCOM products we are having here. And this means that once you've designed a carrier board, this carrier board fits all of our other SOMs. And this is, like mentioned in the beginning, it's very interesting for you for the long-term availability. Like again, like maybe in 15 years from now, ST is deciding to discontinue the MP1. And in that case, it's very likely that we are still having a DHCOM module with maybe an MP3 or MP4 in the program. So then you can just reuse your existing baseboard and populate it with maybe a newer DHCOM module, and then you don't have to do a huge redesign for your existing product. Then again, we're also having the same 1 GB of RAM, and here also you see we're using the same 2-chip design, and of course we're achieving the same advantages like we're having on the DH core. And for the CPU itself, we're of course also supporting all the variants which we are supporting on the DH core side too. So this was the bottom side of the board. Let's continue with the top side of it. On the DH core you can see that we have 2 dedicated Ethernet ports, and each of this Ethernet port is running with a speed of up to 100 megabits per second. And if you're now wondering, why do we use 2 Ethernet ports? Where's the use case for this? Well, if you remember in the beginning, we showed you the DH product portfolio. And there was a device called the DHCOM, which is used as an IoT edge gateway. And here, when you have a gateway application, you of course want to connect it to two Ethernet networks. One is the local area network, and the second one is the wide area network, so it's connected to the internet. And therefore you have a secure application where this is the only device which is connected to your local devices and to the internet. And here you can connect it on the physical levels, and therefore you have a secure application here. But if needed, you also can switch these two Ethernet ports and use a single Ethernet port, and then you can also make speed grades of up to 1 gigabits per second. So it's really up to you if you're using this two Ethernet ports application, or if not, you can also have like a gigabit Ethernet support here too. But while talking about some connectivity, we're also having Wi-Fi and Bluetooth included. And we're supporting here both the 2.4 and the 5 GHz networks. And for both Wi-Fi and Bluetooth, we're supporting the major protocols. And on the Bluetooth side, we're also supporting things like Bluetooth 5.0, and we have also backwards compatibility to older standards like BR and EDR, and of course like the newer ones with the BLE support. On the bottom side, you see that there's a PCB antenna on this module here, and this module also has a dedicated UFL antenna. So the module here is smart enough to detect which antenna is getting a better signal gain. So for instance, if you're not connecting any UFL connector to this module here, this DHCOM module is just relying on its onboard PCB antenna. But in case you're having like a dedicated antenna connected to it, it is switching over to the dedicated connector, and therefore you don't have to mess around with any configuration. This device is smart enough to detect which antenna is getting the better signal. And also very important, this module comes pre-certified, and when it comes for your product to the RED measurement, you can rely onto the pre-certified measurements, and therefore you only have to do some reference measurements in order to make sure that you are still compliant to all the requirements. Other than on the DH core, we are here including multiple storage systems. So we have here a micro SD socket which can be used for the main operating system. Then we of course have also the 2 MB sized quad SPI NOR flash to get again the unbreakable design. And we have also an eMMC flash here. And then you can decide which source might fit your needs. And you can also decide to maybe use a smaller eMMC flash or to populate this DHCOM module with a bigger eMMC flash. An additional feature of this DHCOM module is its real-time clock. Here we're using a dedicated real-time clock because it's very precise, and it's having an accuracy of 3 ppm during the temperature range from -40 to +85 degrees. And to give you some numbers here, this is like an off time of a period of a month of about 8 seconds. And compared to another real-time clock, which might be not temperature compensated and therefore might reach numbers of up to 50 ppm, in that use case you can reach off times of up to 130 seconds. So there's quite a huge difference here. But this real-time clock of course also needs to be provided, and it's very special here too because this is a very real-time clock has a very low timekeeping supply current of about 240 nanoamperes, and therefore you can really max out their battery life. And here our final feature of the DHCOM is its 16-bit address data bus interface. And with this interface you can connect things like an FPGA very easily. Okay, so that's it for the modules. Let's compare them again. So then there is still the question, why do we offer the same SoC in two different form factors, right? And now I want to give you the full answer to it. On the left hand side, you can see we have a family feature set. And this means we have a compatible module. We have the same pinning on all of our DHCOM module, and therefore they're interchangeable. But when talking about such a family concept, you sometimes can't make use of all the features of the SoC. So just imagine, like for instance, one SoC has one CAN bus more than we are having on the family concept. In that case, we can't route these pins to the DIMM connector on the bottom side here, and therefore we're losing some of the features of the SoC. But on the other hand side, we've decided to make all of the pins available on the LGA when you go over to the DH core side. So on the DH core, we have a dedicated pinout on every single module of our DH core series. And therefore you can access every pin and all the features of the SoC itself. So on the left hand side you have the family feature set, and on the right hand side you have all the features which are supported by the SoC itself. And then we have of course also the pluggable design, which means you can interchange these modules very easily. And on the other hand side you have solderable modules, which where of course no connector is needed. And it's quite interesting when it comes to the pick and place module, when it comes to the manufacturing, because you can pick and place these modules just like any other BGA. And to sum it up, we think that the DHCOM is quite interesting when it comes to flexible design and to low and mid quantities of the production. And if you're really if you're really needing the smallest design, and besides, if you're also want to have a very automated manufacturing part, we think that the DH core is the more suitable application here. Okay, so that's it from my side. And next I'd like to hand over to my colleague Andreas, who is continuing with this webinar. Thank you.
Hello everybody, my name is Andreas and I will now take over from Marinus for the last part of the webinar. We will continue with the presentation of our unique cooling solution for the pluggable DHCOM family. The most important thing is that this cooling option is also capable with the new DHCOM STM32MP1 module. The main motivation for this solution was to reduce the CPU temperature without the complex heatsink and to increase the lifetime of the chip. With our so-called 5-band cooling solution, we are mounting the CPU on the bottom side of the module. This gives us the advantage to connect the CPU with a simple gap pad to the mainboard. On the mainboard, we have at this area a copper pad without solder resist. This pad is connected via standard wires to the internal ground plane of the 4-layer PCB. This means the CPU heat can be transferred from the CPU housing via a gap pad to the mainboard. On the mainboard, the heat is spread via the internal ground plane over the whole PCB. In our test conditions, we have mounted our standard Pico ITX carrier board with the DHCOM STM32MP1 module in a small metal housing. This means in a closed box. Then we did the first test without gap pad between CPU and mainboard and started a benchmark test on both cores and an additional GPU benchmark test. With that conditions, the CPU gets 89 degrees hot. This is completely without cooling. Then we add the gap pad between CPU and mainboard and reduce the heat to 74 degrees. In a second step, we did the same test, but additionally we connected the bottom side of the mainboard to a mounting plate inside the metal box via a second gap pad. As I told you before, we are using standard wires on the 4-layer PCB to connect the internal ground plane. Standard wires means in that case through-hole wires, which are also available on the bottom side of the PCB. There we placed again a copper pad without solder resist in our PCB design. So we can directly connect the gap pad between bottom side of the mainboard and the mounting plate. With this second thermal connection, we can further reduce the CPU heat to 66 degrees. In summary, it can be said you can reduce the heat of the MP1 in this example by 23 degrees only by adding 2 simple gap pads to your design. So this is a cost-saving solution which extends the lifetime of the CPU. Now let's come to the software part. On this slide, you find an overview about the reference designs where the board support packages are based on. For the DH core STM32MP1, we have our Avenger board. For this, we offer two Linux versions, one based on OpenST Linux and the second mainline-based Linux version. It is very important to know that we can support the GPU with both available Linux versions. As I told you, the Avenger 96 is our DH core STM32MP1 reference design. This means the BSP supports by default all interfaces of the Avenger 96 board. If you are using additional features of the MP1 in your own DH core design, you will start with the Avenger 96 BSP as reference and adjust the BSP to your needs. Next to the DH core, we have our DHCOM STM32MP1 module. For this module, the BSP is based on our premium developer board. In case of the DHCOM, as Marinos told you, we have a compatible family concept. This means the full feature set of the DHCOM family is supported with our Linux BSP. For the DHCOM STM32MP1 module, we again support a mainline-based Linux version, currently based on 5.4 long-term support kernel. And again, we can support the GPU with this version. On the next slide, I like to explain in a fast way some main features of our software support for the computer on modules. First, as I told you, we support for both STM32MP1 based modules a mainline-based Linux version. This helps us in the further development and above all in the later maintenance of the BSPs for all projects. Then, for all board support packages, Yocto project is supported. The next point is Qt support. Note again, the GPU works also with our mainline version. Then, ST supports also STM32CubeMX for the MP1, so you can use the STM32 family tool for the MPU too. Next to a Yocto-based system, we as DH Electronics also supports a Debian-based system. If this is interesting for you, please feel free to ask. As bootloader, we are using the most popular bootloader for embedded devices, the U-Boot. And as usual for Linux, we have all our sources available on GitHub. On the last software slide, I like to speak about our software support model. First of all, we are doing the BSP porting and maintenance in-house and with partners. This means DH is not only responsible for the module hardware, we are also responsible for the software of our modules. So you get the complete solution from one hand and you have only one contact for hardware and software of the modules. Next to this, we can also do a customer-specific BSP porting to your own hardware. The main software support is handled via our wiki, and if you get in contact with us, you have typically a direct contact to the developers. If we are doing something customer specific for you, for example a BSP porting to your hardware, we are working with support budgets and our ticket system. This allows us to provide a detailed and transparent overview about the provided services. At the last part of the webinar, we like to show you with an example of how powerful the STM32MP1 is. The example is a motor control demo in that case. The motor control algorithm on the M4 was developed by our partner company EDAStream. They are specialists with sensorless control of brushless DC motors, and they are providing a design-in motor control solution based on the STM32MP1 platform. If this demo is interesting for your application, please feel free to get in contact with us or EDAStream. Next to EDAStream, we as DH Electronics can provide a large partner network from several ongoing projects. So if we cannot provide everything for your next project by ourselves, I'm pretty sure that we have a partner who can support the missing part of the project. But now let's come back to the demo application. As I told you, the motor control is running in the M4. The very unique thing on the IDAStream solution is that the firmware can control very low speeds of the brushless DC motor without the usage of sensors. Also, a teaching algorithm is available to adjust the firmware parameters to the specific DC motor hardware. Next to the M4 for real-time motor control, we have our Cortex-A7. The A7 runs a standard embedded Linux on it. A web server on the Linux system provides the current motor data to the outside world, and the Qt web browser with GPU support shows web server content on a local 7-inch display. The data exchange via M4 and A7 is handled in our demo via shared memory in the SRAM. So in conclusion, with the MP1, you have two independent systems running on one chip, embedded Linux, and next to this, real-time bare metal code on the microcontroller. I think this says all. With the MP1, you can realize applications on one chip where you needed in the past two independent controllers. On the next slide, I'd like to show you a video of the demo. In the video, you see the web server content with the motor data, motor voltage, torque, omega, and so on. With a small picture-in-picture, you see the real hardware. I think the video shows very good how well IDAStream handles load and speed changes of the DC motor. And next to this, the Linux system on the A7 provides, without any performance problems, the graphical web server content to the internet. Now, let's summarize the webinar. We as DH Electronics are very proud that we can build the future together with ST and their fantastic new STM32MP1 processor, which fits perfect to the embedded market. And now, as summary, 6 reasons why the Digital Heroes should be your preferred partner. Individual support. Made in Germany. Creativity and innovation capability, availability, tests and certification, complete solutions from one hand, and value-based cooperation. So thank you for your attention, and we are now here to answer all open questions.
Okay, so we'll start off with our first question. Are customer-specific variants of the modules available?
Yes, this is possible. So you can configure your specific DH core or DHCOM variant. This means you can choose typically the CPU type, the DDR memory size, and so on. On our DHCOM, on the pluggable modules, you have much more options available. There you can also decide if you like to have a second Ethernet port or not, or if you like to have a special RTC on the board or not. And so please always have a look at the second page of our data sheets. There you find all the options, and there you can configure your customer-specific variant, and then please feel free to ask us about the prices for these variants. So yes, I think that's all to this question, Yvonne. So yeah, we can.
Okay, we'll take our next question coming from. Yes, we'll take our next question coming from Andrea. Are you supporting SGET Open Standard module standard?
No, this is a very new standard, and the idea is this is also a solderable standard. And the idea with the SGET standard is that this is a family concept. like with our pluggable DHCOMs. But with our solderable SOMs, we don't have a family concept because so they are not exchangeable. And the idea is that we like to have the full feature set of the CPU available on the main board. And this is not possible with a standard like with the SCAD standard. And this is the reason why we don't have a standard for our solderable DH-core modules. Sorry. So yeah, we can go to the next question, I think.
Okay, our next question is coming from Vincent, and it's referring to your slide number 33. And it's regarding the difference between the OpenST Linux and the mainline Linux, because the kernel lines are much different across the two.
Yeah. So mainline Linux means in our case that we are upstreaming our computer modules to the real mainline kernel, and therefore you have always the possibility to use the newest kernel versions. And I think this is the difference to OpenST Linux, because OpenST Linux is always based on a long-term support version. And yeah, you get really, I think, one time a year an update. And in our case, you can additionally to the OpenST Linux, you can also use the mainline version and go with the newest Linux version. And so you have two possibilities. It depends on the project which one fits better. So yeah, I think that's all for this question.
Okay, then we'll go to our next question coming from Salem. For DHCOR STM32MP1, all the schematics are open source. So does DH Electronics provide an open source documentation for the carrier board as well?
That's not true in that case, because the schematic for the DHCOR itself is not open source, but instead the schematic of
Okay, so then we'll go to our next question. Why don't you use the STM32 RTC instead of the externally mounted RTC?
Now I've lost the guys from DH Electronics on that one. I think let's.
First, can you answer that question?
I can't. I don't know what they've done there.
Okay.
Can you hear us now?
Yes,
yeah. It was a technical problem.
Yes. Let me read the last question again to you. Why don't you use the STM32 RTC instead of the externally mounted RTC?
This is an additional RTC. So in Linux, we are using the internal RTC of the STM32MP1. But the problem is that the clock source for this internal RTC is a 32 kilohertz oscillator or crystal. And so you don't have temperature compensation for this crystal. And yeah, so this is the idea, to place an additional RTC with temperature compensation. And so, yeah. So the accuracy is better with the external one. So Linux is working with the integrated, but you can increase the accuracy with the second external RTC if this is necessary for a project. It depends always on the project. If you have an internet connection, so the special RTC is not needed. You can directly go with the integrated one. So yeah, that's all I think to this question.
Okay, then we'll go to the next question coming from Alika. Will future DH core modules with more powerful processors be pin compatible with current modules?
This depends on the family, or they're asking for DH core. So with DH core, we will not pin compatible. So again, the idea is to provide a full feature set to the mainboard. Or you should have the full feature set available on the mainboard, and this is not possible with a pin-compatible standard, and therefore our DH core modules are not compatible. Also, newer ones will not be compatible. Yeah, so I think we can proceed.
Okay, well, next question. Do you have representatives and/or distributors in the United States?
Yes, this is possible via Aero Electronics.
Okay, and our next question, can you share schematics of the SOM?
No, we provide user guides and design guides for the main boards, for the carrier boards, and yeah, this is possible, and also in case of the Avenger 96, the schematics of the main board is open source, but we don't provide the schematics of the SOMs.
Okay, then we'll take our next question from Paul. Is shared memory the only mechanism to communicate between the A7 and M4?
I'll take this again. So the STM32MP1 uses a system of interprocessor messaging. It has a dedicated bus available, and it uses standard Linux RPROC and RP message system communication. Then in addition, for certain shared peripherals, there are dedicated hardware SOM4s available. Hopefully that answers that question.
Okay, then our next question is coming from Michael. What is a typical eMMC part that can be used in the tricky BGA routing manner described?
So the eMMC parts are based on a JEDEC standard, and this means all standard eMMCs have the same pin out, and so you can use with any eMMC, you can use this routing trick which is described in the webinar. So this is possible with any typical eMMC BGAs which are available because they are compatible.
Okay, our next question is coming from Anton. What program is used to check and monitor the electrical characteristics? Marina? Did we lose them again? Chris?
Okay.
Shall I repeat the question?
Sorry, I'm not sure about the.
So we are not too sure what's the concrete point here. So we think if you want to measure some of the electrical characteristics here, you have to rely maybe on some tools from Linux, but I think the more accurate part here is to really put some shunt resistors here and do it really debugging it this way, and to get some accurate numbers about your supply voltage for your use case here.
Okay, then we'll go to our next question. Do you support secure boot?
Yes. So I think it is directly supported from OpenST Linux. And yeah, secure boot always depends a little bit on the application of the customer. So it is supported with OpenST Linux. It's also supported with our mainline-based version. But I think in case of secure boot, the best would be if the customer tells us the needs, and then we can advise which trusted boot chain fits perfect to this project. But it's supported, yeah.
All right, then we'll go to our next question. Why do you provide a Debian-based system next to Yocto with your models?
Yeah, this is very simple, I think. So with Yocto, you build your own distribution. This means you are self-responsible for the maintenance. And with Debian, you are using a real distribution. And this means Debian cares about bug fixes and updates over the next years. And so with a Debian system, you can reduce the maintenance efforts over the next years and for your project. And I think this makes sometimes really sense to use Debian in a project because of this matter.
Okay, then our next question. Why is the long-term availability on page 18 limited to 2 × 512 megabyte DDR memory?
The long-term availability is in that case not really limited to the 1 gigabyte DDR memory, but with 16-bit DDR memory connection, you will need a special DDR3 memory package to support 1 gigabyte, because you need 1 gigabyte in one chip. And this is the main problem, and therefore we have the note on this page, because 1 gigabyte DDR memory in one chip is not a standard part, and therefore we decided to use a 32-bit connection to the MP1, because in that case we can use 2 chips with 512 megabytes, and these are standard parts. And so we can also guarantee the long-term availability with our 1 gigabyte memory option.
Okay, then we'll go to our next question. What about the minimum order quantity of the modules?
Yeah, so for the DHCOM you can order also 1 piece. And for the DH cores, the minimum quantity is 360 pieces, because these modules are delivered in tape and reel packaging. For prototyping, you can also have 5 or 10 pieces, but this is only for prototyping, so the mass production, the minimum quantity is 360 for the DH cores.
Okay, thank you. And what are the dimensions of the modules?
So the smaller one, the DH core, is actually a size of 29 by 29 millimeters. And the bigger one, the DHCOM, is just the size of a standard DDR2 device, and it's 37 by 68 millimeters.
Okay, thank you. Our next question is coming from Marcus. What's the minimal Linux kernel version required or recommended to get hardware accelerated OpenGL?
Should we answer, or?
So I can take this one, Marina.
Okay.
Really it comes down to what the kernel recommended for use from an ST point of view. So as part of our OpenST Linux release, we ship version 4.19, as that's the previous long-term support kernel. Very shortly we'll also be releasing the next package, which will move up to the next LTS, which is version 5.4. So they're the versions we would recommend.
Okay, then we'll go to our next question coming from Antonio about the pre-certification. Which standards are used, 62304 and 60601?
So the pre-certification for our modules is typically based on the European standards. So yeah, we are typically pre-certify our modules based on the European standards. And so yeah, we are typically doing the red test for Europe and for yeah.
Okay, so as we are way over the time that we had scheduled due to our technical problems, if any of you have questions that come up later, please go to www.st.com, navigate to the support button, and log in and answer your question through the online support tool. Again, we will be sending all of you a post-event email with the link to the on-demand view of this webinar, as well as additional resources. So thank you again for attending our webinar on STM32MP1 MPUs and DH Electronics SOM product family. We're very sorry for the delay and the technical difficulties that we had, but we do hope that you enjoyed it and were able to take away some useful information. Also, thank you to those of you who took the time to respond to our survey. We do appreciate your feedback that will allow us to improve your webinar experience with us. And of course, a big thank you to our speakers for making this webinar possible. Stay safe, and we hope you come back soon. So bye.
Bye. Thanks, Todd. Bye-bye.